All right, being a few minutes past the hour here, we want to be respectful of your time. So, good morning, good afternoon, good evening for those joining us from around the country or other countries actually too. Thank you for taking the time to join us. My name is Jared Galligan. I'm the Director of Engineering for Fluence North America. My background is roughly 15 years in industrial water treatment, both on the equipment design and manufacturing side and chemical treatment side of the industry. So, thank you again. I'm joined by Tom. I should add, I'm located in Minneapolis, Minnesota, where it is, I think, 6 degrees this morning. It's plenty chilly. Hopefully, it was warmer where you are. And I'm joined today by Tom Johnson. Tom?
Hi, I'm Tom Johnson. I'm the Director of Industrial Water for North America for Fluence. I'm based in Philadelphia. I've had 15 years of experience in environmental services and engineering. I've worked on about 200 projects across North America, predominantly in the food and beverage industry. My expertise is industrial wastewater treatment, industrial water treatment, water reuse, smart grids, biofuel, and biomass. I have a passion for turning very difficult challenges for companies into assets. And I joined Fluence in 2023, which has been great. It allows me to bring my passion for water reuse and environmental sustainability to the forefront. So I think what we'll do, Jared, do you want to switch to the next slide?
Yeah, what I'd like to let everyone know about is that this is one of Fluence hosts these webinar series monthly on a different topic. You can either view them live here or you can view our webpage if you'd like previous ones on very specific technologies or offerings that we have. Also on the slide screen here is a QR code. That is a link to an online file folder where you can find our case studies on select projects, some of our brochure material, other marketing material. It's just an online folder. I promise there's no registration or sign up or email tracking or anything like that. It's just the raw files for you to review at your convenience. With that, Tom, I'll turn over to you and get us going here.
Okay. Our vision is to become the global provider of fast to deploy, decentralized and packaged water wastewater treatment solutions. The important part of this is the decentralized and the packaged solutions. Decentralized because a lot of municipalities now have not made upgrades necessary to keep up with demand. So they're pushing the responsibility for taking care of wastewater and water directly to the plant level. So we're able to provide small decentralized plants that are very affordable and fast to deploy. And it can really help solve your water problems. Fluence is a global company. We specialize in water and wastewater treatment for the last 30 years. We've done over 7,000 water and wastewater projects in 70 countries. North America is our headquarters, and that's located in Minneapolis, Minnesota. But we have offices and facilities worldwide. We do operating entities and manufacturing in Argentina, Brazil, China, Israel, Italy, and the United Arab Emirates. We also have regional offices in Australia, China, Israel, and Egypt. Since 2022, we've been trying to bring the epicenter of excellence into the United States so that we can pool all of our resources globally. We basically have four divisions. We have municipal water, municipal wastewater, industrial water, and industrial wastewater. Today, we're going to focus on the industrial water market. And within that, we kind of separate things into four areas. We do water treatment plants, which is primarily what we're going to focus on today. We do wastewater treatment plants with a huge variety of solutions. We have anaerobic digestion plants, three different systems. Two of them are proprietary. And we do food and beverage process plants, everything from recovery of organic acids, bleaching, demineralization, and other things. Our industrial market solutions are focused on decentralized treatments, desalinization, wastewater treatment, water treatment, reuse, and waste to energy. The U.S. market has had a comprehensive approach to water and wastewater treatment. So it's very much in line with like a circular water perspective. These things kind of all blend together in a number of different ways. Our industrial solutions include containerized pre-engineered solutions. We're a market leader in desalination and water reuse system, and we have a massive portfolio of solutions for wastewater, many of them with a 16-week lead time. Our North American project focus is on a global team of application, product, and process engineering. We do our main engineering offices are in North America, Italy, the Middle East, North Africa, and South America. We do projects with the combination of people from all of those different areas, international teams that can coordinate the projects along with site supervision and startup. And then after sale, we do remote monitoring. We have the ability to build, own, operate, and we have a number of financing options. So we try to be very market driven and easy to work with. The markets that we serve primarily are meat processing, livestock, value-added protein, dairy and dairy processing, chemicals, pharmaceuticals, paper, food and beverage, and we're growing very significantly in North America. The other things that we do, other complementary treatments, are desalinization, water reuse, and decentralized systems. We have a large, diverse market ranging from $1 million water reuse systems to a $58 million mega project in West Africa that we're working on right now. Today, we're going to focus on water reuse, desalinization, and decentralized treatments. And I'm going to turn it over to Jared to share some of our solutions and some case studies.
Thanks, Tom, for the introduction of Fluence. I just had a couple more slides I'd like to add as it relates to our offering in these markets, and then get into some of our water reuse offerings, some considerations we'd like to make, and some case studies of past projects that we've done around water reuse. So more specifically on the industrial water treatment equipment portfolio that Fluence offers, membrane-based treatment systems, ultrafilter, nanofilter, RO, and electrodeionization are the core focuses, or maybe the most common products that we bring to market. We also do quite a bit with seawater desalination around the world. And then, as this webinar is focused on reuse, is probably our fastest growing market segment out of all of them. And then we have a few special offerings based on the geography, one of them being lithium brine treatment rather, and then ozone systems for bottled water and other beverage products. As Tom mentioned, the key market segments for us on the industrial water and reuse side are food and beverage, power, ocean desalination, potable water or drinking water treatment using membranes specifically, and lithium mining. I included a picture here of some of our recent systems that we've done. You can see, since food and beverage is a heavy focus of ours, many of our systems include stainless steel frames, stainless steel polished tubing or piping, steam sanitizable systems, and everything that goes along with being in these food and beverage process plants. Lastly, I want to call attention to our NitroBox product line. These are containerized systems specifically that use membrane technology, ultrafilter, RO technology, etc. The idea is that they're very modular. So whether we need a project that has one 20-foot container or 20 40-foot containers, they're modular and designed to just be scalable and add on trains as needed. They offer a very quick lead time and are very simple to install with just water and power connections. We handle all of the interconnecting piping that goes along with these systems. And if one isn't sufficient to kind of build on that, we can string multiple unit operations together across multiple containers, as shown here, to build a complete water treatment plant. Tom and I included these slides to kind of give a background around Fluence for those who aren't familiar with us and all of our capabilities. But the heart of this webinar was about water reuse, and that's what I'm going to touch on here. In my inner circle of friends and family, I'm probably the least in the know when it comes to the AI, text, chat, GPT, image creation out there. But for kicks, I went to an AI image generator and I said, give me an image for a water reuse treatment plant. And this was the first image that came back. And so there's a couple things that I gleaned from this. One, even these systems know how complex water reuse projects are, but I thought this was kind of a funny thing that popped up. So, why reuse water? What are the biggest drivers? I listed these drivers here specifically in the US, and the order that they're listed are ones that I and a few others have seen as the drivers primarily in the US. The overwhelming one that we see the last several years is permit compliance. Whether it's a discharge permit to a river, it's a local municipality that can't handle more water. I live in Minnesota, whether it's a particular ion in Minnesota, chlorides are very concerning or very becoming more regulated across the border in Wisconsin. Phosphorus is one of the largest contaminants of concern. Often that complying with a discharge permit or complying to meet with a sanitary sewer uh, system, those have been the largest drivers of doing a reuse project. Secondly, is water availability and demand, specifically in the West Coast states where there is a limited amount of water available to serve industrial users, or whether it's a plant that's there today and they're expanding and they need more water in the local supply, or whether that's a municipality or even a well, the local permitting agency will say, sorry, we can't allow you to take more water. Third, corporate sustainability goals. We've seen most of these on very large global companies will have an initiative reduce the amount of water that their facility uses, their corporation uses. And then lastly, probably the least common one we see in the US so far is to focus around an economic benefit. Oftentimes, water reuse projects do not have an ROI, at least not yet, or if there is an ROI, it's not worth calculating or mentioning. I took this quote from a journal, a recent article. I thought that was kind of fitting that water reuse is a very complex task that requires well thought out solutions adapted to local conditions. As much as all of us think that, oh, water reuse is just a UF and an RO system or some sort of ion exchange system or a filter system, and we can put that in any application we want and it'll work, is short-sighted. It doesn't take into considerations how each plant is so unique based on their water supply and their water discharge, unique to them. From my years of experience doing water treatment and water reuse projects, wastewater treatment projects, just some general advice or terms that I like to include is that it's typically easier to treat water coming into a plant to a higher quality that lets you use it more rather than it is to treat the wastewater that's coming out with the intent to reuse it. What I mean by that is, say a facility has a cooling tower is a large water user in most facilities. It's often easier to treat that groundwater or that city water to a very high quality that allows that cooling tower to use that water more efficiently or more times before you discharge it, rather than take the effluent coming out of the cooling tower and treat it for reuse back into the tower or some other user. And I've listed some considerations there on why that may be advantageous. treating incoming water. The con is you're dealing with a higher volume of water, but a pro is that it's higher quality to begin with. City water, most well waters, even some surface waters in some cases, are higher quality than dealing with a plant combined effluent stream that might have CIP waste, cooling tower blowdown, boiler blowdown, and many other streams included in that makes the system more challenging to design and operate. So as you think about water reuse, either in your own plant or you're helping a customer design their plant, some general points I like to say of what a good project includes. And the number one bold, starred, underlined is a defined basis of design that's built around multiple rounds of sampling that lead to a multiple range of raw water quality that we're designing to. That includes a min, an average, a max, even an extreme case in some situations, and use that to develop a comprehensive flow balance, ion balance, just a water balance for the entire facility if you go forward with this reuse project. And one thing I didn't list here that a lot of facilities overlook or maybe don't consider further on is that if we take wastewater and we treat it to a certain quality, what are they going to use it for? Tom and I have worked on several projects as of late where we treat it to a certain quality that may be higher quality than what the facility receives from the city now, and they kind of say, "Well, where can we use it now? Great, we can save that, but can we actually use it in this process now? Does our corporate standards allow for it?" Um, just something to consider. One other thing I'd like to say is that it's okay to start small with these reuse systems. A lot of facilities will say, "Well, we're gonna focus on a project that cuts our water use in half." And that's great, but sometimes starting with 5% or 10%, you build confidence within the plant through the design phase. Maybe you start with an easier to treat stream that shows your facility is ready for it, you can handle it, you can train operators, and then add on from there as it makes sense as you work down your list of water users to satisfy. And often overlooked as a backup plan. A lot of plants are they do these water reuse projects. These reuse treatment systems can be very complex. They'll have upset conditions. If a main unit operation goes down in the reuse system, what's your plan B? Maintaining the ability to discharge under an emergency situation. You have an emergency pond we've done with a few projects, some storage tanks, whatever that may be. You know, build in yourself an out for when things get upset. Some of the best reuse projects that we focus on, or when we identify a good candidate, is one that gives us consistent water quality coming in. I mean, ideally, that's true with any water treatment system, but it's especially true with a reuse system. We want a narrow window of or a consistent window of what that water quality is. And that goes back to the earlier recommendation of doing large amounts of sampling, multiple rounds, identifying when the best time is, when your plant's worst conditions are, and sample to try and build out that total range of water quality you might see. I say lower organic content is best. Obviously, we can do reuse systems that are just filtration, maybe it's RO. If we have higher organic content, that often lends itself to needing biological systems or biological pretreatment. Fluence has a full portfolio of those systems, but biological systems are costly. And so everything we can do to avoid them or maybe reduce them in reuse systems makes these systems easier to design and lower cost to operate. And then also one other consideration is choosing a stream that maybe has non-sanitary sources included in it. And why I listed that there is oftentimes if you're touching sanitary waste with the intent to reuse that water, even if it's not for drinking water purposes, maybe you want to reuse it for wash down water, etc. That often opens the door to a lot of permitting, a lot of third-party review, and generally sanitary sources to begin with within a plant make up a very small amount of water compared to the overall plant outfall flow. So it's often best to avoid sanitary waste sources if at all possible. Last section here, I want to touch on a few of our recent case studies of water reuse projects to show some examples that other facilities have done, maybe give you some ideas or start the conversation. We're happy to help with. First one is now a Coca-Cola facility located in South America that needed a wastewater treatment plant to begin with to remove organic content from their plant outfall. At the time, it was owned by Unilever. Now it's owned by Coca-Cola. They installed a membrane bioreactor or an MBR-based treatment system. Produces a very high-quality effluent that they're currently discharging to a river. But the reason they Coca-Cola or Unilever at the time could have used a much lower cost or simple treatment system rather than an MBR system. But the reason they went with MBR is they know they want to do water reuse in the future. They're very forward thinking. They thought we probably will have water supply concerns, we're going to have discharge concerns, etc., that we want a system that allows down the road us to be able to reuse this effluent. And so that's why they went with the submerged MBR system. You can see the membranes installed in that bottom picture. They're not reusing the water today because they don't have quite the driver, and then they maybe not have fully thought out the corporate goals or rather corporate quality that they're going to need to reuse this water within the plant. Goes a little shy of a 500,000 gallons a day. So again, not a huge flow, but one, that's certainly not insignificant. Secondly, is another Coca-Cola bottler. This one is in Buenos Aires. Um, they wanted to increase their wastewater treatment plant capacity. They have a very small footprint. It's hard to tell from this picture, but you can see just the edge of a building on the right, an edge of the building on the upper left there, and then there's a large tank in the lower left. So this thing was really shoehorned in there. UF technology is great that way, in that you can very compact for the flow rate, but exact same considerations as the plant before. Um, for reuse, possibility of reuse. Again, they're not doing it today, but they put in a wastewater treatment system that allows them to switch a few valves and begin reusing this treated effluent for in their plant process, whether it's cleaning, wash down, or a host of other users. Another one we did was in a power plant, and this one was a combination of treating high conductivity groundwater that was especially high in chlorides, combined with treating cooling tower blowdown for reuse within the cooling tower. And so you can see from the technology list listed there ultrafilters, media filters, brackish water RO, second pass RO, EDI. There's chemical feed systems, there's CIP systems that make up these that round out these treatment plants, I'll say. They're very complex. They're not just one or two skids that showed up. All these systems are connected within each other that need to be, balanced in their sizing, make sure we're not overfeeding or starving one unit versus another. So again, it sounds relatively simple. We're just taking cooling tower blowdown. We're going to treat well water, but there's a lot of, engineering that goes into these to make sure they are successful. Another one is a major beverage manufacturer, InBev, that was reusing that was treating their effluent for reuse as their plant service water. They had an existing UF there today, or when this project started. The project involved changing out those UF modules and adding on to them to make them more suited to treat plant wastewater. And then we added an additional RO system to produce high quality treated water that can be reused as plant service water, which they use for cooling, which they use for washdowns, and a host of other users. Again, you see the capacity here, 340,000 gallons a day. That's a good flow, but certainly, this facility produces much more wastewater than that in a day. So you can start small with these systems. Similar project we did for a major pork manufacturer. This project happened to be in Brazil, that they had very high organic content in their plant effluent that we were going to use and treat for reuse as service water for, again, cooling, for washdown, for CIP purposes. That we utilize UF membranes along with UV disinfection uh, to prepare that final treated water. This one is much closer to 1 million gallons a day. This one just started up a little over a year ago, performing very well. You can see again from the pictures, all stainless steel piping, or mostly stainless steel piping, I should say. Uh, Again, noting the food and beverage market that it's in. This was another meat processing plant. Again, reusing their effluent water involved ultrafiltration technology only. They were only after reducing turbidity and some large or heavy molecular weight organics that allowed us to use UF membranes only, produced a very high quality effluent that they're reusing as their surface water. Again, looking at that flow there, we're even smaller, 160,000 gallons a day. And this system involved one skid. You can see in that bottom picture there, we combined many different systems, CAP, disk filtration, ultrafiltration, all onto one frame to really make the installation easy and quick for the plant. And lastly, but certainly not least, many facilities, I'd even venture to say most industrial facilities have RO systems today. And a water reuse project doesn't necessarily have to go right to the back end of the plant to be, to be a focus. In this case, we took an existing RO plant that's there today and just targeted the existing RO reject stream of a certain volume. We took that stream, we analyzed it many, many times to build out a profile, and we really just focused it on reducing it. And in the case of this RO reject stream, we were able to chemically treat it and add on an additional RO system and really squeeze down that reject volume. Saves them about 100,000 gallons a day. And that was a relatively simple system to add on to the existing RO system. So don't get caught up with water reuse going right to the back end of the plant, finding this very complex stream. You can start small and do these targeted approaches that allow for savings. This project also included TAMI, which is a Fluence proprietary online monitoring system. There's a screenshot there. Or apology, it's in Spanish from a project down in South America. But this one allows alarms, preventative maintenance schedules, everything to be sent right to your smartphone via text message, online browser, whatever. So, water reuse systems, as I've said many times in this presentation, are complex. So, having that remote monitoring is something that we feel is important and that we include with all of our systems. And with that, Tom and I, that's what we have prepared for today's webinar on water reuse and some of Fluence's capabilities in these markets and some case studies that we featured. Again, these are part of a monthly webinar series. This webinar was that you can review in the past on our website. And by signing up for this one, I'm sure you'll be receiving an email about our next upcoming webinar. With that, we have plenty of time here at the end for any questions that come up. We're happy to stay on for as long as needed, or if you'd like to schedule a few minutes after the fact to talk about a specific project, we're real happy to do so. And lastly, again, the QR code on the screen for those who joined late bring you directly to an online file folder where you can review our case studies, some of our brochures, and some other general marketing information offline at your leisure. So with that, Tom and I are here available for questions. Sherry, Jessica, I don't know if there's anything we need to do to open it up, but we wanted to thank everyone for attending today for sure, and have a great day.
Nope, they can just raise their hand or they can type in a comment, however they want to submit their questions.